Today I will be demonstrating Opturion's Dynamic Transport Optimiser, otherwise known as DTO. The Dynamic Transport Optimiser is used to assign a set of orders which need to be picked up in one location and delivered to another, to a set of vehicles which may or may not be compatible with that order. So what we see on the screen presently is a scenario that has been loaded, each dot on the map representing a location. So for instance, if we click here, it brings up information about this location. For instance, there are no pickups, but there is a delivery. At the moment, as we haven't run the algorithm, nothing has been assigned, and there are no minutes time associated with this order yet. So all of this information can be viewed for scenarios within the menu in the UI, and these can be edited here. So for instance, we have all of our orders, we have all of our locations. So you can see location 1 represented here on the map, as well as our vehicles. So for instance here, information about the vehicle, including its start and finish location. So if we return to the dashboard and actually run the algorithm, clear menu, we can see here the locations turning from red to green, representing as orders are being assigned. So at the moment we've assigned 198 out of 200 orders. And if we look up here, we can see that there is a couple of warnings present about this scenario. So as the algorithm runs, we find an initial solution, and this is improved upon with each iteration. And what I'm going to do is stop here. And one of the benefits of this algorithm is that you do not need to wait until the end of the run to get a compliant solution. Each solution found through the solving process is itself a compliant solution. And by that, I mean that it respects all the constraints, and it's the best the algorithm has been able to find to that point. So we've been able to assign 198 out of our 200 orders. And if I actually click up here, one of the useful things we can see here is information about why 2 of our orders weren't assigned. So order 4, no vehicle can arrive at the finish location before the latest finish time, and the closest vehicle could have arrived 28 minutes late. And order 9 has a volume of 117, and the largest fleet capacity is 30. So this is very useful for debugging, particularly typos and things like that. Down the side, we can view our locations. This is our solution. If I click on each location, I can see the information about what's been assigned at that location. But more interestingly, here are the routes for each vehicle. Here we can see the route for vehicle 1. Present here, you can see the start and finish locations, as well as the various stops that this vehicle made along the way. To break this into its individual legs, we can select the menu here. And we can see for each leg, there's a start location. In this case, warehouse 1, where it had 1 pickup. It did 1 delivery at location 107. This was a transit distance of 20.31 kilometers, and it took about 25 minutes. And using this, we can step through the routes or the legs that this vehicle did as part of its route. We can also view this information as a run sheet. So for each vehicle, we have the run sheet here with their arrival and departure times, the type of stop, and what was done at that stop. So for instance, here we have a pickup of order 107 from this warehouse. And this information is viewed across the bottom here, and we can see each box with a plus represents a pickup, and a box with a minus represents a delivery, and breaks are represented here by the coffee cup. We can also see KPIs. So for the KPIs, for vehicle 1, these are our time KPIs. This vehicle was working for 599 minutes. The lowest in the fleet was 68, and the highest was 600. So this is one of our highest working vehicles. Similarly for transit, it's 46 minutes of transit time. Was the lowest in the fleet, 455 the most, and this vehicle was a little bit less. Similarly for distance, as well as weight and volumes with the costs. And we can step through each vehicle up here. The final thing we can see is the route editor. So what this allows you to do is to move orders between vehicles and to check that against the KPIs. So for instance here, if I decide that I actually want to move order 175 to a different vehicle, what will happen is the solver will perform a check in the background, And we can see here the warnings associated with this. Now, obviously, I've just moved one order and it's going to collide with others here. But if you choose to highly modify the solution, you can do that and then see what's actually happened. So for instance, how this has affected the various KPIs, so cost, number of orders, the distance traveled for your modified solution versus the optimized. So once again, thank you for watching this video. If you have any further questions, please don't hesitate to reach out and we can arrange a time to show you a demo which contains a full list of the various constraints and features present within the DTO platform. Thank you.